So let me pick one of these loads, the one I just picked before. So let's pick ZL is equal to 2, normalized is right here. I'm picking the real part of 2, imaginary part of 0. And let's suppose that I'm adding now a shunt inductance whose value is Y inductance normalized is equal to negative J2. And the question is, what is now my Z in? So if you didn't have the Smith chart, you would basically have to do the normal thing that you know how to add admittances, but let's do it with the Smith chart. So first, I'm going to start my ZL and calculate YL. So I'm starting with 2, and I'm calculating YL, which basically means take the antipodal point and land right here. So YL is basically equal to 0.5. Now that I have my admittance YL, I can go ahead and add the admittance of the inductor, which is negative J2. So that basically means I'm going to end up with an admittance which is equal to 0.5 minus J2, which will be right here. And what I really want you to notice here is I'm basically treating my Smith chart the same way for admittances as I'm treating it for impedances. So I had the number of 0.5. I added negative J2, so I moved negatively. And basically, I end up now with an admittance of 0.5 minus J2. That is the admittance right here. In other words, this is exactly Y in. So Y in, this example, is 0.5 minus J2. And so if you now ask the question, OK, you just found Y in, can you please find Z in? The answer is absolutely. I can basically start with Y in, take the antipodal point of the Smith chart. Hopefully, you can draw a better straight line than I did here. And if you do the straight line correctly, and obviously I didn't do it here, you will find out that Z in, just by reading it on the Smith chart, is going to be equal to 0.12 plus J 0.45, 0.47. All right, so there are basically two interesting transformations that we did here. We started from ZL. We looked at the antipodal point. We ended up with YL. Then we added admittances the same way I would have done it with impedances. So here's my admittance Y in. And then I did one more transformation right here to basically find my ZL, my Z input, which is probably somewhere closer to here.